Good morning, grade 8.
Good morning.
How are you today? Fine?
Yes.
Today we are going to make our weekly review worksheet number 4 for semester 1. The lessons we are going to revise in this review sheet are lesson 2, LCM and GCD of two numbers, lesson 3, congruency and right triangles. Are you ready to start?
Yes.
Okay. So the topics covered in this week were how we calculate the LCM and GCD of two or more numbers. Which method did we use to calculate the LCM and GCF of two numbers? I didn't hear you. Prime factorization. And the second topic, apply rules of congruency in right triangles. How many rules of congruency in right triangles do we have? How many rules? Two rules. The first rule is they are congruent by HA. What do we mean by HA? Hypotenuse angle. The second is by H. What do we mean by H, Al Hassan? Hypotenuse. Hypotenuse leg. So we will start with question number 1. Read question number 1, Selena, in a loud voice.
Given the three numbers 36, 48, and 60, write the prime factors of the three numbers.
So we should write the prime factors of these three numbers. What's the first number, Badia?
36.
So we should write the prime factors of 36. Yes, Badia, we divide 36
By 2.
by 2 it's
18.
18. We divide 18 by 2 it's
9.
9. 9 by 3
3.
is 3.
1.
By 3 it's 1. So the prime factors of 36 are, yes, Badia?
2 times 2 times 2. 2 times 2 times 3 times 3.
So the prime factors of 36 are 2 times 2 times 3 times 3. Hassan, can you tell us what are the prime factors of 48?
Yes.
Yes.
2,
By 2?
24.
Yes.
2, 12.
By 2?
12. 2, 6.
By 2? 6.
2, 3.
By 2? 3.
3,
By 3?
1.
So repeat, Hassan, what are the prime factors of 48?
2 times 2 times 2 times 2 times 6.
Now the prime factors of 60, Dana.
Divide by 2 is 30.
By 2, 30.
By 2, 15.
Yes.
By 3, 5. By 5, 1.
By 3, 5. By 5, 1. Now we will write the prime factors of each number. The prime factors of 36 are
2 times 2 times 3 times 3.
the prime factors of 48 are
2 times 2 times 2 times 2 times 3.
okay. The prime factors of 60 are
2 times 2 times 3 times 5.
okay. So these are the prime factors. Now, Ala, we should find the GCD of 36 and 48. Can you tell us, Ala, in GCD, what do we choose? The least common divisors. What do we take in GCD? We take the more common or the less common? Between 36, we want 36 and 48, Ala. Yes, what do you choose? 2 times and 2 4 times. What do you take? So we take 2 times, 2 times 2, and we take 3 1 time. Can you calculate the GCD of 36 and 48? The GCD is 12. What do we have another name for GCD? What do we call the GCD? GCF, greatest common factor. Now, after we calculated the GCD of 36 and 48, we should deduce the GCD of 36, 48, and 60. Can you tell us, Ali, how can we find or deduce the GCD of the three numbers?
The GCD of the 36 and 48 are
So this GCD with what?
with the 60.
With the prime factors of 60. Between these two, we should deduce the GCD. Yes.
We write 2 times 2
So we take 2 times 2.
times 3.
Do we take 5?
No, because it's not
Because 5 is not common, so it is 12. Now, we should find the LCM, Muhammad, of 36 and 48. In LCM, what do we take, Muhammad?
the greatest common.
More common and not common. So between 36 and 48, Muhammad, if we have 2 times and 2 4 times, what do we take? So we take 2 4 times. 2 times 2 times 2 times 2.
Times 3 times.
Yes, we take 3 2 times. It is 2 times 2 times 2 times 2 times 3 times 3. Let's calculate it. 2 times 2, 4 times 2, 8. 8 times 2, 16. 3 times 3,
9.
so we should multiply 16 times 9, 144. Now, after we calculated the LCM of 36 and 48, we should deduce the LCM of 36, 48, and 60. What do we use? We use the prime factors of 60 and the LCM of 48 and 36. Can you tell us, Dana? We take 2 times or 2 4 times?
2 4 times.
Yes, so we take 2 times 2 times 2 times 2.
Times 16.
How many threes?
3 times.
Yes, 3 times 3
Times 5.
times 5. So this is the LCM of 36, 48, and 60. Anybody has any question about how we calculate the LCM and GCD of more than 2 numbers?
No.
Everything is okay?
Yes.
Okay. Now we move to question number 2. Read question number 2, Hassan.
Find the following.
Number 1, we should find
The following.
which is the GCD.
25 and 31.
We should find the GCD of 25 and 31. It's equal to what? It's equal to 1. Can you tell us, Hassan, why it is equal to 1?
Because 25 and 31
Is a
relative difference.
25 and 31, we call them, so 25 and 31 are relatively prime numbers because their GCD is 1. Now, Dana, find the LCM of 25 and 31.
And number 1 times number 2.
The LCM is equal to, what is number 1? 25. What is number 2? We multiply 25 by 31. The answer is 775. Now, number 2. Do you want to solve it, Badia? The next one. Given you have 2 numbers, number A and number B, but here we are given their prime factors. From these prime factors of A and B, we should find the GCD, Badia.
2 times 2.
So we take 2 squared because it's of the lower power. Do we take 3?
No,
Why?
because
It's not common, yes. Between 5 squared and 5, what do you choose?
5.
We choose 5. So 2 squared is 4 times 5 is equal to 20. The GCD of these 2 numbers is 20. Now, Ali, we have x equal, it is a number, it's given in this form 12 times 15, and y is equal to 9 times 20 times 4. Yes, Ali?
What write the prime factors of the 12?
We should write the prime factors of the numbers of x. Okay? First, is 12 prime?
No.
So what should we find? The prime factors of 12. How do you write 12?
2 times 2 times 3.
It is at the beginning. It is 3 times.
4.
It is 3 times 4. So we write 12 is 3 times 4. What do you write 15?
3 times 5.
So 15 is 3 times 5. Now, is it 3 prime?
Yes.
Is 4 prime? No, so we write it 3 times. What is 4?
2 times 2.
4 is 2 times 2. Is it 3 prime?
Yes.
So we write times 3 times 5. Okay? Now, y is equal to 9 times 20 times 7.
We want to make 9.
What is 9?
Prime factors for 9.
3 power, 3 times 3.
9 is 3 times 3. 20 is?
4 times 5.
It is 4 times 5. Is 7 prime?
Yeah.
So we write times 7. Now, is it 3 prime?
Yes.
Is it 3 prime?
Yes.
Is 4 prime?
No.
No.
Is 5 prime?
Yes.
So 4 is not prime. We write 3 times 3 times. What is 4?
2 times 2.
It is 2 times 2 times 5 times 7. Now, from these factors of the first number, which is x, and from these factors of the second number, which is y, from these two prime factors, we should choose what? The GCD. Can you, Selena, choose the GCD?
3.
First, we start with the smallest number, which is 2, right? In the first, we have 2 times. In the second, we have 2 times. What do we take? 2 times. So we write 2 times 2. In the first, we have 3 times. In the second, 3 times. We take, so times 3 times 3. We have 5 one time, 5 one time. We take 5 one time. Do we take 7? Why? Because 7 is not common, so this is the GCD. How can we calculate this in an easy way? Yes, yes, Selena? 5 times 2 is 10.
2 times 3 is 2 times 7, which is 18. 18 times 7 is 180.
Good. 180. Yes, it's 180. Any question?
No.
So correct. Now question number 3. Read question number 3 Ala in a loud voice, please.
Vertex A, what's that BC equals 6 centimeter and the ABC triangle B equals 2.
Wait, Ala. Whenever they say we should construct an isosceles triangle, of what should we think? Yes, Ali. This triangle has 2 equal sides and 2 equal angles. Before we construct, we should say what are the equal sides and what are the equal angles. Because the vertex is A. If this triangle has a vertex A, what are the equal sides? We said that the equal sides are issued from the vertex, right? So the equal sides are AB is equal to AC. What are the equal angles? Angle B is equal to angle C. Now we continue. Side BC is equal to 6 centimeter. Are we given side AB?
No.
Are we given side AC?
No.
Does the side help me here in this construction? No. We are given angle ABC equal 50 degrees. What's the vertex of this angle? B. If angle ABC is equal to 50 degrees, which angle is equal also to 50 degrees? So angle C is equal to 50 degrees. Here we are constructing a triangle knowing only the angles? One side and 2 angles. Which rulers do we use here? We use long ruler and protractor. First, we should construct the side which is what? Which is BC 6 centimeters. So, this is side BC, which is 6 centimeter. Now, what do we use? We put the protractor on the vertex B and we assign an angle which is what? 50 degrees. We also put it on the vertex C, which is also 50 degrees, and we join with the vertices. We join the first one with the vertex B, we join the second one with the vertex C, and we get what is the name of this triangle? A, B, C. So before we continue, what are the equal angles? B and C. So angle B is equal to angle C. What are the equal sides? Side AB is equal to side AC. Now we continue. We should draw what now? What is BM? An altitude relative to AC. It should be issued from where? From B. What do we mean by altitude? Perpendicular to AC from B. So we use the set square, we put it on AC, and we draw an altitude which is BM. And we draw the other altitude which is C what? CN. This is the other altitude, CN. Okay? Now read the question, the next question, Ali.
Show that the two triangles BMC and BNC are congruent.
BMC and BNC are congruent. If you look at these two triangles, what's the nature of these two triangles? They are right triangles. So we should here use congruency in right triangles, either by HA or HL. First, if in the first triangle BNC, what's the right angle? BNC, what's the right angle? N. Who's the hypotenuse? BC. In the next triangle, which is BMC, if the right triangle is M, who's the hypotenuse? So what do we say here? BC is a common side. So we have in right triangles which are BMC and BNC. What do we have here? First we have, yes, BC is a common, it is a common side. What do we call it, this side? Hypotenuse. And what do we have also in these two triangles? Angle NBC is equal to MCB, because the triangle is isosceles, each one is equal to 50 degrees. So what can we say now, Badia? These two triangles congruent by HA. Okay, because they are congruent by HA, now we should name the homologous elements. What are the homologous elements? First, let's name the sides. Name the sides, Hassan. BN is equal to MC.
And BM equal to CN.
And BM is equal to CN. These are the sides. We have angle N and angle M are 90s, right? Yes. Angle B is equal to angle C. Which angles are also equal in these two triangles?
MCB and MBC.
Yes, Ali?
MCB.
M angle NCB NCB is equal to MBC. So these are, what do we call these? We call them homologous elements. Okay. Now in triangle ABC, angle B is 50 degrees, angle C is 50 degrees. How can we calculate angle angle A, Muhammad? In triangle, look at triangle ABC. Angle B is 50, angle C is 50. How can we calculate the above angle A?
180 minus 50 plus 50.
So angle A equal, from the sum of angles in a triangle, 180 minus,
50 plus 50
yes, 50 plus 50,
equal
180 minus 100 degrees. So angle A is equal to
80.
80 degrees. Anybody has any question?
No.
Do you understand the congruency in a right triangle?
Yes.
Okay, thank you. Well done. Okay. So we finished the congruency of BMC and BNC. We stated the homologous elements. Now we should deduce that AM is equal to AN. Yes, Ala.
AB equal AM plus NB.
AB is equal to
AM plus NB.
A-
AM
AN
plus
plus NB. Yes.
AC equal AM plus MC.
AC is equal to AM plus MC. Yes.
AB equal AC.
Because triangle ABC is isosceles, we have AB is equal to AC.
NB equal MC
From the homologous elements, MB is equal to MC. What do we get now? We get AN is equal to AM. Okay?